Okay, in this video, you're going to learn about points of concurrency in a triangle. Okay, first, it sounds like an intimidating word, right? So what does it mean to be concurrent? So concurrent in mathematics means meeting at a point. Meeting at a point. Similar to converging. Okay, so there are 4 points of concurrency in a triangle, and they each have a name. Okay, we're going to use this chart that I'm going to make to memorize the points of concurrency. So you're going to make a chart that has 3 columns and 5 rows. Okay, 3 columns and 5 rows. Okay, so the title for the first column is going to be mnemonic device. The title for the second column is going to be what converges. Okay, what they are, what the items are that converge. And then the third column is going to be what the vocabulary word is for the point of concurrency. Okay, so the mnemonic device is my, parents, anger, aliens. What converges, okay, goes by the first letter. So this is going to be medians. P stands for perpendicular bisectors. AN stands for angle bisectors. And AL stands for altitudes. Now the vocab words go in alphabetical order. Centroid, circumcenter, incenter, orthocenter. Okay, now one thing you want to keep in mind, okay, is if 3 segments intersect at a point, they must intersect where any pair of them intersect. So we only need to have 2 medians to get a centroid, 2 perpendicular bisectors to get a circumcenter, 2 angle bisectors to get an incenter, or 2 altitudes to get an orthocenter. Okay, but you should write this down though. If 3 segments, okay, lines or rays, intersect, they must intersect where any pair of them intersect. Okay, therefore, we only need to do 2 constructions. For each point of concurrency. Okay, you're not going to be responsible for these constructions. I've done them, and I'm just going to discuss them with you. But you will not have to be able to do these constructions. Maybe I'll make it an extra credit project. So the first one is the centroid, which I've completed on the left. Okay, how do we know that these are medians? So what makes a median? So number one, you would have a perpendicular bisector. So for instance, I did, right, this construction here, which gave me this perpendicular bisector. Why would I want that? Because a perpendicular bisector passes through a midpoint. Once I made that perpendicular bisector, to get that midpoint, I have to connect the midpoint to the opposite side. So this, for instance, this red segment here, okay, is a median. Okay, this blue segment is a median over here. So where this blue and this red segment intersect, that is the centroid. Okay, the significance behind the centroid is it's the center of gravity. So what that means is that if you were to have this triangle and you were to balance it at the centroid, it would be parallel to the ground because it's the center of gravity. Now the centroid, by the way, is always inside of the triangle. Okay, let's look at the incenter. So for the incenter, here's what I did. I did an angle bisector. So for instance, I made this arc. Then I made these two arcs and I connected that up. That was an angle bisector. Then I did the other one. And then I connected that up. Where these two intersected is called the incenter. The incenter will always be inside as well. Okay, what's the significance behind the incenter? Well, I made this circle in the picture. I'm not going to hold you responsible for making this circle either. But this circle is called the incircle. And the significance behind the circle is that it shows that all three sides are equidistant from the incenter. All right? So this is called an incircle. And the significance is that it shows that the incenter is equidistant from all three sides. And that's your incenter. So no matter what kind of triangle you have, it doesn't matter if it's acute, right, or obtuse, it will always be inside. Same with the centroid. Okay, that brings us to the circumcenter. Don't know why this scanned a little blurry, but this is the circumcenter. So what I did for the circumcenter, I started with an obtuse triangle, and you just do the perpendicular bisectors. You don't do the medians. Okay, so this is a perpendicular bisector. Okay, then in red I have another perpendicular bisector of this side of the triangle. Okay, where they meet is the circumcenter. So here the circumcenter is outside of the circle. So if the triangle is obtuse, if you have an obtuse triangle, the circumcenter is outside, always. Now in the second triangle, I have a right triangle. Let's go through this one. So I did the perpendicular bisector, okay, of this side here. Then I did the perpendicular bisector of this bottom side here. Okay, and the two of them met at the midpoint of the hypotenuse. So when you have a right triangle, okay, the circumcenter is on the hypotenuse. Okay, in the picture on the bottom, I did the perpendicular bisector of this bottom side, right? Then I did the perpendicular bisector of this right side. And so where they met, where they intersected, is the circumcenter. And so it's in. So in an acute triangle, it's inside. Acute triangle, circumcenter's in. Okay, so I did do something else in this picture. I made a circumcircle. So the significance behind a circumcircle, so the circumcenter is the center of the circumcircle. If you look at these three vertices, it shows that the three vertices of the triangle are equidistant from the center. So that's the significance. So the circumcircle shows that the vertices, and this will happen in each type of triangle, it doesn't matter which type of triangle you have, that the vertices of the triangle are equidistant from the center. Whereas in the in circle, it was the sides. Okay, the last vocab word was orthocenter. And for an orthocenter, you have the altitudes, as you know. So I started off, I did an altitude, okay, just to do it, which it didn't matter because in a right triangle, the altitudes are always all going to meet on the vertex of the right angle. So the orthocenter in a right triangle, okay, the orthocenter is at the vertex of the right angle. Okay, so in the second picture, I have an obtuse triangle. So you can see I made two altitudes. I made this altitude here. Okay, I extended it. So I was trying to see where it would intersect the other altitude I made. Now, in order to make this altitude that I have in red, I had to extend the side of my triangle. See that dashed segment? That's because I had to extend it, and sometimes you'll have to do that. At any rate, you can see that these will eventually intersect quite a bit off. I would have to keep going down, right? And I would have to keep going left. Eventually, they would intersect. But all I need you to know about this is that in an obtuse triangle, and this is obtuse because look at this angle, guys, right? So in an obtuse triangle, the orthocenter will be outside, just like in a circumcenter. In an obtuse triangle, the circumcenter is outside. So in an obtuse triangle, the orthocenter and the circumcenter are outside. Okay, the last picture is an acute triangle. And just like everything else we've learned, okay, the orthocenter is inside. So for every acute triangle, all the points of concurrency are inside. All four of them. Okay, so you can see where they intersect. right, you could certainly draw the pictures in your notes, but I will show you how to do these constructions, but I'm not going to hold you accountable for these constructions, nor will the regents, okay? They will be putting this in the curriculum in new generation standards, but that won't affect you. Okay, I apologize in advance for the scan. It didn't come out the best, but that's the best I got going on here with this technology. So in this picture at the right, we have the circumcenter O. These are perpendicular bisectors. So they give me the measure, you could see, of MO, right? MS, NR, and NO. So they ask us for the measure of MO. Well, keep in mind that the vertices are equidistant from the center. So since N is 26.8 away from the center, M would also be 26.8 away from the center. Okay, so that means that MO is 26.8. So now we want PR. Well, PR is the same measure as NR, because when you have a perpendicular bisector, it passes through the midpoint, so the halves are equal. So this is 26. MN, well, MN is going to be twice MQ, because MQ is half of MN. So that means this is 40. SP is going to be the same as MS, because they're equal halves. Then they're asking me here to find the measure of angle MQO. So remember, it's a perpendicular bisector. Okay, so here in this picture, okay, that angle is a right angle because it is a perpendicular bisector. So MQO is a right angle, so it's 90 degrees. If OP is 2x, and we want to find x, we know that 2x equals 26.8 because P is equidistant from the circumcenter. So x equals 13.4. Okay, so those are problems that have to do with the circumcenter. All right, let's take a look at the incenter. So for the incenter, remember we're dealing with the angle bisectors. So it says the point T is in the incenter. And we know that when you have the incenter, it's equidistant from all three sides. So we want to know point T is the point of concurrency of the angle bisectors. So we want the measure of ST. So if you're looking at ST, okay, that's going to be equidistant from T as W is. Okay, you could make an in circle here to help you. Okay, so that is 15. Then it says TU is 2x minus 1. But we know that TU has the same measure as ST. So therefore x equals 8. The measure of angle PRT, so PRT is 24 degrees. So that's this little angle here. And we want the measure of angle QRT. Well, QRT is the same, guys, because an angle bisector splits an angle into two equal halves. Then we have angle RPQ. RPQ. That's this angle here. They say that this angle is 62 degrees, but they want the measure of angle RPT. RPT is half of that. So that would be 31 degrees. Okay. Next, we have the centroid. Okay, so the majority of questions on this topic are going to be about the centroid, because the centroid gives us ratios, okay, that exist because of these medians. So first, let me tell you what these ratios are, or I could just tell you as we go. We'll just tell you as we go. So we have RS is 4, we have VW is 6, and we have TV, that's the entire length of TV, is 9. So what you need to know is that the centroid splits a median, this is a median, it splits it up into a 2-to-1 ratio. Okay, so you should write that down somewhere. A centroid divides a median into a 2-to-1 ratio. Now, the 2 part always goes from the vertex to the centroid. So it's vertex to centroid to median, or to midpoint, we should say. Okay, so let's take a look at the question. So we want the length of RV. Well, V is a midpoint of RW, so it has to be the same as VW. So it's 6. SU. SU is half of RS. So since RS is 4, SU is 2. RU is the 4 plus 2, or 2 times 3. So the ratio of RU to SU is 3-to-1. Or you can just find SU and multiply it by 3. So we have 2 times 3 is 6. RW. So RW is 12, because it's the length of that entire side. TS. So when you want the measure of TS, you know that the measure of TV is 9. So divide 9 by 3, you get 3, right? So this piece is 3 from S to V, and this piece is 6 from T to S. So TS is 6, and SV is 3. All right, take a look at the 2 problems on the bottom of the page here. We have that FG, again, we have a centroid, but we have that FG is x plus 8, and GA is 6x minus 4. Well, GA is twice FG. GA is twice times FG. So your equation would be 6x minus 4 is 2 times x plus 8. So this gives you 6x minus 4 is 2x plus 16, which 4x equals 20, so x is 10. Number 46, they're saying CG is 3y plus 7. Then they say that CE, which is the whole thing, is 6y. So the thing is that CG, there's a couple of ways of approaching this, but CG is 2/3 the size of CE. Or you could say that, we could either say that, or we could say that CE is 3/2 times CG. Either or. I'll just leave it the way I have it. So I have 3y plus 7 is 2/3 times 6y. I can cancel the 3 into the 6, getting a 4y. 3y plus 7 is 4y, therefore y is 7. And that concludes this video. So we'll be working more on this during our in-class flipped work tomorrow. Thank you.